Okay, so we're going to try this again. I have a better microphone this time, and hopefully y'all will be able to hear me better. Today we're going to start a new unit on polynomials. So we've talked about polynomials before, but we're going to go into a little bit more detail in this unit. So here is our official definition of a polynomial. And you will never need to know this. It just not in real life, not for the test, not for the ACT, but there are a few things you do need to know. So I want to point those out to you. The A's here, all of these with the subscript, those are just numbers. And that first number, the one labeled A sub n, is called a leading coefficient. It's the one in the front. And we've seen this before when we were talking about quadratics, about parabolas. The number at the end, the one labeled A sub 0, that's our constant term. The thing that's new is this idea of n is the degree of the polynomial. The degree is the largest exponent that we have. One more thing to point out. It says we can't let that leading coefficient be 0, right? This A sub n is just a number, but if that number is 0, then this whole part goes away, and the polynomial that we have left, this part, has an entirely different degree, right? So we don't want that leading coefficient to be 0. We would just leave off that part entirely and just write the new polynomial with the new degree. So let's look at some examples. Here I have a constant function. Is it right here, right along here. F of x equal to 3. So what's the degree for this function? That is kind of a tricky question, right? What's our biggest exponent? Well, where is even our variable? We don't have a variable. So here's the tricky part, right? X raised to the 0 power, anything raised to the 0 power, is equal to 1. Excuse my really bad handwriting. So if we have 3 x to the 0, that's just equal to 3. So even though we don't write that on there because it's kind of silly, we could write it like that if we want. Let me see if I can erase. I'm trying to remember how to erase. No, that's not it. That is definitely not it. Oh, that's a dotted line. Oh, there's an eraser. Yay. Okay. Sorry about that. Okay, so it's not really erased. The degree of a constant function is 0. The maximum number of zeros. Now remember, 0 is just another name for a root, also called a root, or an x-intercept, right? So this function has 0 x-intercepts. Let's look at another example. How about a linear function? Here we have the function x plus 2. What's the degree? Again, this is a little bit tricky, but remember, if we raise anything to the first power, right, x raised to the first is just x. So there's an implied 1 right there. Sorry about that line. So the degree is 1. The maximum number of zeros, the maximum number of x-intercepts is 1, right? It's right there. There's the x-intercept. So try to imagine, right, drawing a line. Can we draw a line that has more than one x-intercept? Well, no, because if it crosses once, it would have to bend to cross again, and lines don't bend, right? So it either has no x-intercepts or it has 1, because the maximum is 1. Let's look at a quadratic function. Here's an example of a quadratic function. So the degrees, again, is the biggest exponent. So we have degree equal to 2. And you see now, why does it keep doing that? We've got 2 x-intercepts. And that's the maximum that we could have, right? Because my parabola could be up here. Oh, that's really lousy. And it has 0 x-intercepts, right? Or it could be right exactly on the line. Stop that. And just have 1. Oh, so the maximum number of zeros, the maximum number of x-intercepts is 2. Just for fun, what's my leading coefficient on this one? Right? We've talked about this before. It's that number that's out in front. And in this case, there's not anything in front of the x squared, right? So my leading coefficient is an implied 1. Right? That's my leading coefficient. So here's a cubic function. I don't have an equation written for this, but just make a guess, right? What would the degree be for a cubic function? A cubic function has an x cubed in it. So the degree is 3. And the maximum number of zeros, the maximum number of x-intercepts, is 3. So what about a quartic function? Well, I'll just take a guess. It's going to have an x to the 4th in it. So the degree is 4. Maximum number of zeros is 4. And in this graph, you can see we've got 4 zeros. 4 x-intercepts. Now, there's this really nice pattern that holds, but there's one exception. There is a constant function that has more than 0 x-intercepts. If we draw a constant function right on the x-axis, we actually have a line with an infinite number of x-intercepts. I know it's kind of weird. So the function f of x equal to 0 is kind of the oddball out. But we're not going to worry about that very much. Okay, so here we've got the different names of the different functions and how they're written in standard form. Now for lines, we learn somehow it's always mx plus b, right, where m is the slope. But we could write it with an a because it's a number, right? It's just a number. So that could be the general form for a line. This is our standard form for the quadratic. We learned that already. For a cubic, I'm going to try to write on here. We'd have a times x cubed plus b times x squared plus c times x plus d. For quartic, y equals a times x to the 4th plus b times x to the 3rd plus c times x squared plus dx plus e. And for a quintic, y equals a x to the 5th plus b